Welcome to the DIY Honda Garage channel. This presentation focuses on DTC P16F3, which indicates a low voltage issue in the starter cut relay 1 control circuit of the 2016 to 2022 Honda HRV. This diagnostic trouble code, DTC, is logged in the Powertrain Control Module, PCM, when the vehicle experiences difficulties related to starting. When the DTC is triggered, it signifies that there is a malfunction in the starter cut relay circuit, which is essential for safely starting the engine. The starter cut relay plays a crucial role in preventing unauthorized engine starts, which is vital for vehicle security. This diagnostic process aims to identify the sources of the issue systematically and rectify them to restore proper vehicle functionality. DTC P16F3 pertains specifically to the starter cut relay 1, which is responsible for controlling the engine's starting process. This relay essentially acts as a gatekeeper, disabling engine start to prevent unwanted ignition. Located within the underhood fuse relay box, its primary function is to interrupt the circuit that allows the starter motor to engage when necessary. The relay facilitates communication between the ignition switch and the PCM while executing the commands that signal when the engine should start or remain inactive. A low voltage condition in this circuit indicates either a wiring issue or a malfunctioning relay, which hinders proper vehicle operation. Diagnosing DTC P16F3 involves several potential causes, which must be examined independently. First, poor connections or loose terminals at the starter cut relay 1 and the PCM can create resistance, impacting voltage levels. Next, a shorted wire within the ST cut relay 1 CL line could lead to direct contact with ground, resulting in low voltage. Similarly, an open wire in the same circuit might disconnect the signal entirely, failing to communicate the start command. Fuse failures, such as a blown fuse, particularly number C26 7.5A, located in the under-dash fuse relay box, can also deactivate the relay. Each of these faults can contribute to low voltage issues affecting the relay system. The primary symptom of DTC P16F3 is an inability to start the engine, which may present as the vehicle failing to turn over when attempting to ignite. The presence of this DTC can be confirmed through a diagnostic scan, revealing both confirmed and pending code statuses. Intermittent starting issues may lead to frustrations, as the vehicle may start at times but fail at others. Such irregular behavior usually indicates underlying electrical problems that prevent adequate power from reaching critical starting components. Observing these symptoms helps technicians pinpoint the source of the issue for effective resolution. The first step in troubleshooting DTC P16F3 involves performing an engine starting check. Begin by attempting to start the engine while ensuring all other systems are functioning correctly. If the engine starts successfully, it indicates that the immediate components may be operational, and you will proceed to the next step for further verification. Conversely, if the engine does not start, this indicates a deeper issue that requires additional investigation. It's crucial to monitor the behavior of the dashboard indicators and any unusual sounds from the engine, as they can provide further clues to the underlying problem. In the second troubleshooting step, begin by powering down the vehicle to the off-lock mode and then turning it back to the on mode. This reset might clear temporary faults within the system. Using the Honda Diagnostic System, HDS, proceed to clear any diagnostic trouble codes. Once cleared, conduct a thorough scan to identify any pending or confirmed DTCs. If DTC P16F3 appears again, It confirms that the underlying issue persists. However, if the DTC does not reappear, it may indicate an intermittent fault that should still be monitored. Properly clearing codes and rechecking can reveal systemic issues requiring attention. The third step focuses on checking for shorted wiring in the ST-cut RLY1CL line. Start by switching the vehicle to the off-lock mode. Then jump the SCS line with the HDS. This action allows you to bypass certain circuits temporarily for diagnostics. Next, disconnect the PCM connector A51P and remove starter cut relay 1 from the underhood fuse/relay box. Use a multimeter to measure the resistance between the designated test points. If the resistance is 1.0 megaohm or higher, the wire is clear of shorts. If the resistance is lower, it suggests a fault in the wiring that must be repaired for the vehicle to function correctly. Next, conduct a comprehensive starter system check while ensuring the vehicle is in the on mode. In a continuously variable transmission CVT layout, place the transmission in P or N, while for a manual transmission, MT, shift to neutral and press the clutch pedal. Furthermore, use the HDS to observe the relevant parameters while attempting to start the engine. It's vital to check if the starting control return signal corresponds with the threshold conditions indicated in the diagnostic protocols. If all current conditions meet the necessary thresholds during starting, the circuitry may be deemed operational, necessitating a shift to the next troubleshooting step. Any discrepancies indicate more severe issues that require dedicated attention. In troubleshooting step 5, focus on identifying potential failure areas, starting by switching the vehicle to the off-lock mode. As before, jump the SCS line using HDS and disconnect the PCM connector A51P. Switch to the on mode and use the appropriate transmission setting for engine testing. With everything in place, measure the voltage between specific test points. This test checks whether battery voltage is present without the PCM connected. If adequate power is detected, proceed to update the PCM if necessary. If issues persist even after replacing with a verified good PCM, more comprehensive diagnostic protocols will be needed to address unexplained failures. For the sixth troubleshooting step, an open wire check is crucial for the ST-cut RLY1CL line's integrity. Start with the vehicle turned off, lock mode. Then remove starter cut relay 1 from its housing within the underhood fuse relay box. Change the vehicle to on mode and check continuity between specified test points, ensuring the PCM connector and starter cut relay are still disconnected. A successful continuity test indicates that the ST-cut RLY1CL line wire is intact. If there is no continuity, however, this indicates an open circuit, necessitating corrective repairs. This thorough examination eliminates the options of wiring issues that contribute to the DTC persistently reappearing. The seventh step involves checking the associated fuses that may impact the starter cut relay circuit. While the vehicle is turned off, lock, specifically inspect fuse number C26, rated at 7.5A, found in the underdash fuse/relay box. If the fuse is intact, it prompts action to examine the next component in the circuit. However, should you find the fuse blown, immediate troubleshooting is required to identify potential shorts between the fuse and the starter cut relay. Allowing a blown fuse to remain undetected could lead to other system failures, preventing proper engine operation. Thus, ensuring that this fuse is both functional and correctly rated is critical for correct circuit behavior. In the final troubleshooting step, inspect the IG1 ST-cut RI line for continuity. Start by disconnecting the underdash fuse relay box connector Q 40p, and use a jumper wire to connect specific terminals to body ground. This process helps verify the connection to the starter cut relay. Check for continuity between the test points described, applying similar precautions as in previous steps. If continuity verifies sound wiring, the IG1 ST cut relay wire is functional. Should continuity fail the test, properly repair the wires to ensure adequate connectivity. Repairing these lines is vital in restoring the starter's ability to engage properly. After completing all troubleshooting, the final repair verification requires thorough checks to ensure everything functions as intended. Utilizing HDS, rescan for any lingering DTCs to confirm the issue has been fully resolved. It's essential to also attempt to start the engine several times under different conditions to make sure the repair holds in various scenarios. Documenting all repairs performed, including replaced parts or updated software, provides a precise record of the actions taken. This step not only confirms that the current issue has been addressed, but also aids in future diagnostics if similar issues arise. A comprehensive closing assessment encapsulates all steps taken in alignment with manufacturer protocols. Preventive maintenance is crucial to ensuring the longevity and reliability of the starter cut relay system. Routine inspections should include closely examining the wiring for signs of wear, corrosion, or damage that could lead to faults in the starter circuit. Additionally, testing the functionality of the starter cut relay at regular intervals can help detect early signs of failure before they escalate into more significant problems. It's also essential to ensure that all connectors are well secured and free from foreign debris, which can affect electrical connections. Keeping these maintenance practices in check contributes to the overall performance of the vehicle and minimizes the chances of running into DTC P16F3 in the future. In conclusion, addressing DTC P16F3 requires a methodical approach to troubleshooting that begins with understanding the specific components involved. Systematic checks of the starter cut relay, associated wiring, and PCM can isolate the root cause effectively. Each step helps ensure that all electronic connections are secure and operational. Preventive maintenance plays a vital role in avoiding future DTC occurrences, reinforcing the importance of regular inspections. By following the troubleshooting steps outlined and adopting a proactive maintenance strategy, technicians can effectively manage and resolve issues related to the starter cut relay circuit in the Honda HRV. Please like and subscribe to the channel. See you next time.